This is our third video on oscillations. In today's video, we are going to look at the difference between just a bob pendulum and a physical pendulum. So a quick recap from the last video. We were looking at where we just have a simple bob on a string. And so by having that bob on a string, we could convert this equation where we have that the period is 2 pi square root of the moment of inertia over LmG, using the moment of inertia for a point mass, which is what a bob is, we could simplify that down to 2 pi square root of L over G. Now the thing becomes, what if our pendulum is something different? What happens if it's not just a bob on a string? So when we are dealing with a physical pendulum, we have a distribution of mass. So we cannot cancel. So this I, that is our moment of inertia about our pivot point. The h is going to be the distance from the center of mass to the pivot point. So you'll notice that that doesn't necessarily take the entire length of the object. And m is going to be the entire mass of the pendulum. So we can't always just simplify it super quickly. So we have three basic ways that we can calculate the period of a pendulum depending on what type of pendulum we have. So if we have a simple pendulum, this is our bob. And if I want the period for this simple pendulum to be twice as long, this length is going to need to multiply by 4 because of that square root. Now, if I start looking at my torsion pendulum, well, that's where I'm going to need to look at this twisting constant, or the moment of inertia, how the mass is centered about that point. So this is my tire swing, or the disc swing, if you will. Then we have our physical pendulum. This is where we have, like, I'm thinking literally like a baseball bat, and it's swinging about the handle. That is a physical pendulum. So these periods can include G. You see that in the simple pendulum as well as the physical pendulum. And that's partially because it is swinging with the force due to gravity, whereas that torsion pendulum, that tire swing style pendulum, it's twisting. So another way that we can continue to look at simple harmonic motion, we could look at it as viewed on edge. It is the projection of uniform circular motion about a circle. Now, if you've done the unit circle in pre-calculus, this is kind of what we're looking at, those X and Y pieces. So you start seeing that sinusoidal behavior as we model through it. So this is where we're going to end for today. We're going to have some problems in mastering physics. So find me questions and let me know what they are.